All right, let us talk about a new kind of graphical display. It is called a mosaic plot. And so this is a new evolving type of graphical display that makes it such that in one glance you can give even more information than just looking at a plain categorical bar graph. All right. You could even have up to 4 different categories shown at one time. So very interesting. All right. So the first thing I want us to do is take a look at these two graphs. These came from, I believe it was 2018 data of the, actually, no, it was 2019. So it was the 2019 scores for Calc AB, Calc BC, Computer Science A, Computer Science Principles, and Statistics. And these were AP scores. And then the distribution of the exam grades. When you take the exam, you can get a 1, 2, 3, 4, or 5. And so here on the left, we have the distribution of those grades per type of exam. But over here on the right, it looks different. So we want to think about what is different about it and what that could mean. So think about that for just a second. Well, hopefully you can see that the widths are different and they are touching together. Now, they are touching together not because they are number values that will connect together, like we'll discuss in a histogram in a next unit. Okay, they are touching together just so that you can more easily compare them. But what's interesting is why do you think that some of the bars are wider than the others? And what we notice is that these different widths have to do with how many tests, or the proportion of those total exams given that make up the Calc AB and the Calc BC and so on. The proportion of the total exams given. So, which test was most common? Had the most tests given? That was your Calc AB, and the highest proportion of tests. How about which one was the least? Well, I can see the skinniest one. It looks like the science principles is a teeny bit wider than computer science A. All right, so that's what's happening. And so right here we say, what additional information? The varying widths on the x-axis give us a proportion of all AP exams given that were the Calc AB, Calc BC, CSA, CSP, and Stats, okay? That were those particular types. Now, so the key is mosaic plots are this type of graphical display that will give us the proportion of the totals. Okay, and they will not violate the area principle. So if they look twice as big, then there is twice as many proportionately to the totals. And so I just had some pictures here because I thought it was interesting to see how these types of graphs show up in uh, other types of industries in the world. So here, this first one showed from the most to the least traded finance stock. These were stocks. And this was the technology stocks from the most traded to the least, and then the healthcare stocks. So it's kind of interesting. The bigger areas are proportionately how much bigger those stocks were traded. Next, let's take a look at this one here. We have eye color and hair color. And so here is a two-way table. You know, we've just come from our two-way tables. Well, here is this information in a mosaic plot. Okay, so let's talk about, you know, what's happening on the x-axis. So what I see here, you know, is these varying widths of the x-axis. So what is the x-axis? These things telling me those varying widths, and I think that's the first question asked. Label what the various axes represent and explain what the various widths and heights represent. Well, the x-axis is the proportion of all the subjects in this sample. proportion of the total that are black hairs, person, brown-haired person, red-haired person, and a blonde-haired person, okay? So it is the proportion of the total. So the proportion of the total, that's important because the y-axis is different. So x-axis is the marginal distribution, the overall distribution of the overall black, brown, red, and blonde-haired individuals. But the y-axis has all these different heights. Do you see the different heights in each category? So I do not want you to say that it is the proportion of each eye color. If you say the proportion of each eye color, you are saying your denominator is the eye color. And that is not what these heights are. These are varying heights because they are sectioned off based on the black-haired individual. So if you have black hair, conditional upon you being a black-haired person with black hair, here is the rate at which you have brown eyes, blue eyes, hazel eyes, and green eyes. Next, conditional upon you having brown hair, here's the rate at which you have brown eyes, blue eyes, hazel eyes, and green, and so on. So the y-axis is representing the conditional upon you being each one of these categories on the x-axis, the rate at which you had those height, those y-axis things. So here's how that could be written. The proportion of each hair category. You have to say it in that order. If you say the proportion of eye color, that's wrong. Then that's saying your denominator is the eye colors, and that's wrong. It is the proportion of each hair category, the black-haired people, the brown-haired people, and so on. The proportion of each haired category that are brown, blue, hazel, and green eyes. It's conditional upon you having those hair colors, the rate at which you have those eye colors. Now, this is an interesting mosaic plot. It takes the same information, but it kind of separates it by gender. So we have 3 categorical variables here, hair color, eye color, and gender. So what happens is you can see that each one of the bars was split according to the proportion that were male on the left, female on the right. So see, look in the redheads. That's interesting. In the redheads, I can see that there's a higher proportion of females than males. So that'd be interesting, to see overall if that's what's happening. And in the blondes, higher proportion of females than males. I wonder if those are natural blondes or not. Okay, moving on. So advantages of a mosaic plot. You can have up to 4 categorical variables. We could even do it 4 at one time. In some ways, the comparisons can be seen easier. So that's a good thing about mosaic plots. But there are some disadvantages. It can be difficult to compare certain heights when they're in different locations of the mosaic plot. And I'll demonstrate that on the next page. It may be difficult to compare those, the blue-eyed people because they're in different locations in the mosaic plot. Let's see, because I wrote this looks lengthy, because of the varying heights and widths, the equal areas, we'll look at this I'll come back to this as the last example that we're going to get. Because of the varying heights and widths, it's interesting. You could have an area that represents 15 people, and you have another area that's a different shape. One of them, or say it was 16 people. One was, it was 2 by 8 area, and that was 16 people. And then the other one, maybe it was a 4 by 4 area, a square, and that was our 16 people. And so it was hard to see, though, that those 2 different sections were the same area because of their different shape. So we'll talk about that. And finally, some technological displays are limited and they may not line up correctly. And we'll see that on the first problem in the assignment that we look at. All right, so let's look at examples of some of these things that are difficult to tell. Here we go. So it's hard to visualize these heights. For example, are these two blue highlighted areas the same height? Okay, are those two blue highlighted areas the same height? I don't know. What about it is difficult to compare the proportion of black-haired people that are blue-eyed and the proportion of red-haired people that are blue-eyed. Are those two proportions the same height? Very difficult. See? So, that's just even hard to see that this was a blue section and this was a blue section. So, there's just some things that could be difficult. See, it would be much easier to compare different square or rectangles in the mosaic plot if they were lined up on the same axis. Okay, so there's kind of a disadvantage with the mosaic plot. All right, let's take a look at this because we're going to kind of talk about this real life graphs, and it's very interesting. So, do you know what the polio vaccine is, and or what polio was, and what polio did? It happened in the 1950s, and in fact, I want to kind of look that. I like to look that up here, kind of, and show you some pictures of what was happening. So, when we had some of the kids that had the polio, then what happened was they were being paralyzed. We even had some pictures of the iron lungs, and what happened with that was people could not uh, they were paralyzed maybe from the neck down, and so then their body was not able to pump and squeeze and do all the different things with their lungs. So these were called iron lungs. So they had gymnasiums full of iron lungs. This person here, he was the last of the iron lung users. Okay, and looky here, this. So these were it was traumatic. So polio was a traumatic event. It was affecting young, even more so than the older. All right. So here's a couple of just graphs. Let's take a look at them. This, we were interested in looking at the vaccine and seeing what it did as far as protecting you from the symptoms or the side effects of getting polio. So here we go. We have in green the ones that were vaccinated. The gray is those who were not vaccinated. Okay. And so we can see in each age category, the 0 to 4, 5 to 9, so the different ages and the percents who took these people all took the vaccine, and or actually the green were vaccinated, and look, 40% of these ones became paralyzed. But look at the gray. Of the not vaccinated people, 70% became paralyzed. So in every category, in every age category, we can see that those who were vaccinated were getting paralyzed at a lower rate than those who did not get vaccinated in every category except for the 10 to 14-year-olds. And maybe that's because we had a small sample. I don't know. All right, let's see what this graph shows. It's different. This is talking about just how many people were in the study, and then we can see that in that vaccinated, in that 0 to 4-year-old, sorry, we had a lot of, we had half of them, there was 34 or whatever, half 34 that were vaccinated and 34 that were not vaccinated. So this is just giving us the number of people and the vaccination or non-vaccination situation. So the number of people. All right. So with that background, let's now take this. This is the same data, but in a mosaic plot. So let's examine. So what three categorical variables does this one graph display? So I can see the orange and the green are representing paralyzed or not paralyzed. Okay. I can see that the width of this is representing vaccinated and not vaccinated. Remember, the 0 to 4-year-old, about half of them were almost half, it was identical. Half were vaccinated, half were not vaccinated. That's why these widths are the same. And then it's chunked off, sectioned off, and split by, a larger gap by age. So here is kind of that delineation of the age groups. Okay, so let's take a look at some questions. So that was the first question. The three categories are paralysis, yes, no, vaccinated, yes, no, and then your age categories. So next, what can you tell about the age categories from this mosaic plot? Well, based on how wide this is, I can see that, look, there was hardly any in 40 plus year olds, not very many, what is this, 10 to 14-year-olds. I can see that most, or a higher proportion were of the subjects in this study were 0 to 4. Okay, so that's what I wrote here. Largest proportion of patients were 0 to 4. Smallest proportion of patients were 40 plus. Does this mosaic plot appear to indicate, what does it appear to indicate about the relationship between the vaccination and your paralysis? Well, let's go look. Okay, so vaccinated was this second bar of the ages. Well, look in all of these categories. The green section in the vaccinated bar, except for in this 10 to 14-year-olds, that's the same. But in every category, every age group, except for 10 to 14-year-olds, the vaccinated green section, which is the non-paralyzed, is larger. So I can see in every case, in every age category, except for the 10 to 14-year-olds, in which it was the same, the vaccine had lower paralysis rate, had higher no paralysis. Okay. I can easily see that the orange areas, the paralyzed patients, are taller on the non-vaccinated than the vaccinated. All right, next question. What kind of data are we able to get from bar graph 2 on the previous page that we are unable to get from this? Well, let's see. On bar graph 2, it told us the actual number of patients. See, we could see there were 34 in each group in the 0 to 4-year-olds. So we were able to actually get the specific counts of how many. There was only 5 in 10. There was 10 to 14-year-olds total. 5 vaccinated, 5 non-vaccinated. And look at this 40 plus. Looks like there was one person who was not or vaccinated, and 5 were not vaccinated, and so on. So we could see actual numbers that we aren't able to tell here. We can kind of get an idea of how big they are, but we can't tell numbers. All right, this is important, or this is very interesting here. So here, look at this. So if we looked at this table in the 5 to 9-year-olds, 15 were vaccinated, no paralyzed. 15 were paralyzed, no vaccine. Okay, but anyway, these two numbers were the same. And look at this right here. This is 15, and this is 15. So I don't know exactly how that how that 15 is broken down. But look at the because of the different heights and widths of this, it is very difficult for me to see that this orange area is the same number of people as this green area here because they are different shapes. So that's another problem with the mosaic plots. All right. So overall, so interesting, so much interesting things we can tell with the varying widths and that depth that mosaic plots give us. All right. So FYI, this is an assignment that you're going to be doing. I just want to give you a heads up before you do it. In fact, you know what? I think I'll. No, you know what? This was a disadvantage. Let's take a look at it. So this was again the classifications on the Titanic, and that's deaths and survivals. But look at what this is very interesting. There's this line here. This line is indicating the delineation between the children's section and the adult section. This being red down here at the bottom says there were no children. It's empty. It was blank. No children in the crew. And that's good. No child labor going on here. Okay. But look at what happened. See, this was one of the disadvantages I was talking about. One of the disadvantages is that the computer program that did this put child right here. But the child information is not until down here below that line. Okay, so that was just one other disadvantage is that computer software gave an unclear representation of where the different categories were located and hard to tell the difference between them. Okay, so that's all we know about mosaic plots, and I hope that's an interesting new graphical display for you to look at.